Got it. Okay. Let me stop this thing real quick. Okay, and then go here, hit done. I want to share my screen. Right now. So welcome YouTube and scholars. Let me see. So this will serve as our full lecture for, this is the top of week 3 for College Algebra 2, and we're going to be working on section 3.1. So the main thing is, I think this is what, week 3, sorry, I said week 2. This is the top of week 3. And I think we are scheduled for exam 1 to be next week, right? So the sections that we've covered so far, what I think it's like 1, 7, 2, 5, and now we're doing 3.1. Those three, whatever 3 sections we've done thus far are what you can anticipate on exam 1. And so the way I do my exam, so again, everything is available outside of lectures and exams. So exam 1, which is week 4, that should be available. I usually make it available for the entire week. So I think it's like maybe that Monday. I don't remember. I know, but all I know is that it's available for like a week, right? You get like a full, it should be about 7 days where you can earn full credit, like you can earn up to 100% for the first 7 days. Whatever day is due, usually have it due at the start of our next meeting time. Let me think about it. It should start next Wednesday. It's either next Wednesday or next Monday, but whatever time it starts, and you'll see it. If it doesn't open up on Monday, then it'll open up on Wednesday. But whenever it starts, it should be 7 days if you have access to it, where you can earn up to 100%. And then once the due date hits, you can actually still work on it again with unlimited attempts past the due date, but then there's a 10% late penalty, right? And then also with my exams, it's like I kind of do like this pool technique where basically what's going to happen is like each time you take the exam, it's going to be a different exam, right? It'll be the same content, but just a different exam. So you want to do the best you can to have some level of confidence going into it. You know, just do the best you can, because again, at some point you will find yourself in like a testing environment. You're going to be responsible for this. I don't know when and how, but that's generally what happens, right? But for right now, just kind of do the best that you can. Okay, so with that, let's go ahead and kind of work on homework for section 3.1. I want to say you can follow along, but again, it's going to be, if you like work on your homework as I work on mine, it'll be the same questions with different numbers. Now I think last time, I don't know if it was this class or not, but I know one of my classes, someone had a question, but they didn't speak up, right? Because I noticed that once we were wrapping up class. So, we don't have to talk about these questions in particular. I just go through these just to kind of fill the air. But again, the intent of the setup is for these to be Q&A. So like, if you want me to go over something else, or if anything's not clear, you just have to get my attention, speak up, unmute yourself, that kind of stuff. And we can talk about anything that you like to talk about. Okay, so with that, we will go ahead and get started and get through as many questions from section 3.1 between today and Friday, okay? And yeah, we have I think our exam 1 will be available next week. Let me see if I can pull up. Let me see if I can see right here. If I go to my manage, come on. Have your exam 1 scheduled to be available the 2nd, which I think is next week, right? Let me look at the calendar. Is a week from today. So exactly 7 days from pretty much now, exam 1 will become available, and then it should be due like 7 days later. It's due on the 9th, right? Okay, so you got to see the official date. So starting next Wednesday, the exam will be available, and then it'll be due the following Wednesday at the start of class. You can work on it past that time, blah, 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 blah. Okay, so this example, we have given this function, we're asked to find f of -4. So we're working on exponential functions, right? So what makes this an exponential function is because we have the variable in the exponent, right? Um, so this one, we're just evaluating an exponential. So it says when x is -4, we're basically plugging in -4 for x and then evaluating the exponent. So then we're going to have 1 minus -4, right? And in that instance, it's a double negative. So it's really 1 plus 4, which is 5. So then 2 to the power of 5, what is that, 32? Okay. And again, if anything is not clear, you just have to stop me and we can talk about it. All right. So all I did was plug in x was -4 though. Let's keep going. And again, what makes these exponentials is because our variable is in the exponent. So this exponential function evaluate when x is 2.8. So for this one, we would use a calculator. So I'm going to go ahead and pull up my trusty dusty rusty. This guy is having to reload it fast, but again, I've organized, so I know how to find my file quickly. At least I'm not wasting a lot of time looking for it. Reload and refresh. If I'm just evaluating the exponential, I'm going to type this into my y equals in the upper left-hand corner. All right, so I'm going to click on the y equals. Let's say I'm going to do 4 caret or 4 to the power of, I'm going to do parentheses 1 minus x, right? So because basically given whatever x value I plug in, it'll spit out the desired result. I'm going to quit. Now to call on that function, to the right of the calculator, kind of in the middle, you see a button, the clear button, like if you want to clear. To the left of that is a button that says VARS. I'm going to click on that for variables. I'm going to go to the right to go to Y variables. And basically, I'm going to click on number 1 for function. I'm going to click on number 1 again for Y1. And basically what this is doing is calling up that function that I had just typed in, right? So now what I'm going to do is basically I'm going to evaluate this function when x is 2.8. All right, so I'm just plugging in 2.8 and I'm going to hit enter. And it says round to 3 decimal places. So when x is 2.8, then I get 0.082, right? So I'm going to plug in 0.082. Okay? So just proper rounding. The 4 tells us to round down or stay the same, in other words. Next question. I just suppress my trusty dusty rusty calculator. Okay, this one, given the function, we're asked to find h of -3. So when x is -3, right? So again, we're going to have 1 minus a -3. So that double negative becomes positive. That becomes 1 plus 3 is 4, right? So then we're going to have a quarter to the power of 4, right? Four. So basically, we need to do like I need to do 16 times 16, right? So 16 times 16, 10 times 16 is 160. It's 60 plus, we got to do 6 times 16. So 160 plus 60 plus 36. 160 plus 36 is 196 plus 60 is I think it's 154. I think that's it. So we're gonna do, I'm just doing this off the dome. Obviously I can use my calculator. Daggone it. I think I got 154. Let's do 1 over 154. Let's just give that a go. Let me try that again. 16 times 16. So that's a 10 times 16. So that's 160. And then 6 times 16 is 60 plus 36, which is 96. 154. Where? just trying my mental math. Wasn't that successful this time. So what I'm going to do, I'm just going to type 1/4 to the power of, and just to kind of drive the point home, I'm going to do 1 minus parentheses -3. Right? I could just do to the power of 4, but you know, this is the same thing. Oh, and then I'm gonna hit math as a fraction. But yeah, it's okay. 256. Something I was missing. 256. Research to see, probably do some other mental math techniques, right? Okay. Function that contains these 2 points shown below. So they give us these 2 points. We're going to model an exponential function to pass through these 2 ordered pairs, right? So I guess I could write this one out, and I probably should. So let me start by, let me pull this up over here. This usually helps. I'm thinking about, like, I kind of want the header just so I know which question this is. I just don't like how jumbled it is, but I also didn't want to make it like wide. So I was just trying to think of aesthetically how I wanted it to look. This will suffice for now for what I'm trying to do. So I have a copy, I have a portion of the header, the information. So that way, like if I were to ever call in these notes in the future, no, I know what it's referring to or where it comes from, right? I think that helps. Okay. Let's see. So we're asked to find an exponential function. Now we're going to model it. We're going to get these 2 points. We want it to pass through f of x equals c times a to the power of x, right? So basically, let's just plug in each of these points, right? So this first one, thank you. Oh yeah, we got a short class. Yeah, this is why I do so many things outside of classes. Like you blink your eye and our class is over. This is only 50 minutes. And like 15 of those minutes is like taking attendance and getting set up. Even when I am like waiting for you guys, it still takes just that amount of time to get going. So if we plug in this first point, right? When x is 0, y is 3. So let's plug those in. Our y is 3, c times a, and we said x was 0, right? A to the power of 0, this collapses to the number 1. So this means that c is equal to 3, right? So that first order pair, you know, when we started this, we had essentially 2 unknowns that we're trying to solve for. We're trying to solve for c and a. So each time we have an unknown, we need an equation, right? So this piece of information gives us one equation to work with. This piece of information gives us a second. Every time you have an unknown that you're trying to solve for, you need a piece of information. Okay, so then from this first piece of information, we get that c is 3. Then let's take this and plug it back in and use the second piece of information to solve for a. So now when x is 2, y is 12. So then we're going to have 12 equals, now we just said that c is 3. A is the only thing we don't know, and x is 2. Now at this point, we have one equation, one unknown, we could solve for that missing component. So if we're going to solve for a, we want to start moving things away from the a. We can divide both sides by 3. I'm going to just reverse the order. We get a squared. 12 divided by 3 is what, 4? Okay. We take the square root. Now, normally when we do square root, we do plus or minus. But I think for this context, we said the base is going to be positive. You can't have an exponential with a negative base. It won't behave like an exponential. So for our discussions, the base of these exponentials, we're just going to take the positive. Our model ends up being, if we plug in our C and our A, and let me highlight them here. I mean, essentially you can see the C here, and here's the A. So then if we plug those in, times 2 to the power of x, right? And we can confirm that this works for both points before we submit it. Okay. When x is 0, this is gone, and the answer is 3. When x is 2, 2 squared is 4, right? 2 squared is 4, 4 times 3 is 12, right? So they both work out. Okay, so we're going to hop back over to Pearson. Me. The wheel thing says it's loaded. 3 times 2 to the power of x. 3 times 2 to the power of x. I think that's okay. Let's keep it open. Let's go on to the next question. Let me check Zoom really quickly. It's okay. Okay. This, so we have f of x equals 5 to the power of x. That takes on the general shape of an exponential, where the general shape of an exponential, it kind of like starts off flat, nearly flat, going along the x-axis. And then once it passes through the point 0, 1, and then it just takes off exponentially. It's like a B, right, over here. It's similar to B. Let me zoom out to make this look a little bit better. B is the only one that has the proper shape. I want to say that A is the shape of a cubic, C is the shape of a linear, D is the shape of a log function. So the only one that takes on the shape, we didn't really do any transformations. I know that the base is 5. What that does is like causes a vertical stretch by a factor of 5, I think it is. But it doesn't really distort it. It just kind of stretches a little bit, but it still takes on the general shape of an exponential, right? We didn't like flip upside down or move left to right or anything like that. So this one should just be B. Again, A is the wrong shape, C is the wrong shape, D is a log function. Logs kind of come up vertical first along the y-axis, then they go off to the right. So D is a log function. So then we're gonna just go with B. Let's see now. So notice that our base, we have f of x equals 1.5 to the power of negative x. Notice that the base is larger than 1, so it still would normally take on the shape of an exponential, but now the general shape of an exponential, but we made the exponent negative, right? We put a negative inside our base function. So when you multiply negatives inside your parent function, that causes a horizontal flip over the y-axis, right? So instead of starting off flat and then growing exponentially, this is an example of exponential decay, where it's going to come down quickly and then come nearly flat, right? So it can't be C or D. Those I think are going in the wrong direction. So then we have to decide between A and B. B, I think it causes that 1.5. I think it causes a vertical stretch. Let me think about it. I think it's a vertical stretch, right? All right, so when you change that base like that, that affects the y value. So I'm just going to go with B. Right? And now we could, if we weren't sure about the shape, we could like choose different values of x and verify the corresponding y. Like use our calculator, choose different values of x. We can plot the graph and graph it ourselves, or just look at the graph on our graphing utility and match the window size. Like make sure the windows are the same, and then that might be one way. But I was basically using transformations from college algebra. Let's check that. Must be A. Let me think about something really quickly. Suggest the points too. Let me look at one other thing. Okay, if it's not A, then maybe I missed something. Vertical stretch. Okay, well, let me try A. So let me think. Okay, so maybe I should have go ahead and like and I was kind of totally taking advantage because I'm like, it's multiple choice. But it probably would have been better if I just chose a few values of X and verified them. So we at least got the shape correct. Let's try this one. Let me see, y equals 0. So we didn't move it up or down. It looks, let me see. 3, 4, 5. Okay, I'm having a hard time. So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So it is passing through the point 0, 1. When X is 1, 1, 2, 3, 4, 5, 6, 7. Y is 7. I feel like it's just A. Like we didn't move it up or down. We didn't flip anything. I think I'm gonna just go with A, right? It's the general shape of an exponential. Let's go with A and call it a day. Okay. Transformations, right? We have y equals 3 to the power of x plus 3. So all it is should be the generic exponential shape, but then we move it up 3 units because we had that plus 3, okay? So when we go to graph it, the exponential is, in this one is going to be the bottom left, so I'm going to click there. It says click the graph to plot, so I'm just going to click the origin. So now the base, I think the base is already set to 3. Only transformation that we did, we moved it up 3. So we're going to, this vertical shift, we're going to slide it to 3. That's the only change. Okay. I'm going to check Zoom really quickly. Chat looks okay. Sketching, right? So the parent function is the exponential. We have a total of 1, 2, 3 transformations, right? We have 3 transformations. Hopefully you can identify or see those 3 transformations, right? So here, so the parent function is still exponential. So it's going to take on this shape. Instructions say click the graph to plot. So I'm just going to click the graph. It opens up this menu. Okay. Okay, I think we're good. Now, the first transformation is whenever we're doing our transformations, my recommendation is work your way from the inside to the out, right? So the inside, the innermost transformation is that -2, right? So we subtracted the 2 inside our base function. So that's going to move the graph. Inside manipulations cause a horizontal change. If we subtract 2 on the inside, that should move it to the right by 2 units. So horizontal shift to the right by 2 more. The next is that 5, right? We're multiplying the outside of our parent function by 5. So outside manipulations usually cause a vertical change. Find the outside by a number larger than 1, that's going to cause a vertical stretch. So we want to cause a vertical stretch by a factor of 5. So I'm going to slide this bar over to 5. And then we added 1 outside our base function. So that's going to cause a vertical change in the form of moving the entire graph up by 1. So vertical shift up by 1, right? So this one basically was just capturing the 3 transformations. I'm going to close this. Okay, you can see it shifted up by 1. We didn't move it side to side at all. We caused a vertical stretch. Oh, we moved it right by 2. Again, if it lets me, it did it a moment ago. I'm going to go with it. Let me hit save. And let's go with that. See my time. Oh, on a sad day. We got about 6. I don't want to keep it no longer than another 6 minutes. Okay, so describe how the graph can be obtained from the graph of the basic exponential function 2 to the power of x, right? Let's see, we shifted the graph of this left to, no, we went right to, so it's not A. We stretched it vertically and shifted down 1. No, we didn't go down 1, so it's not B, so it should be C by process of elimination, right? We said we went right to, stretched it vertically, and then shifted it up 1, yeah. So we're gonna do final check. So that question was all about transformations from College Algebra 1. Okay, so another graphing one. So now this is a exponential base E. It's just the natural base E. Okay. Function is the upper right in this instance. So I'm going to click on the exponential. I'm just going to click anywhere because that's what instructions say. So now we have a slightly different menu to capture the transformations. Notice it says the base is E. We have a total of 2 transformations going on here. We got a -5 inside our parent function. That's going to cause it to go to the right by 5 units. Horizontal shift 5 units. So I'm going to just type a 5 there. And then the +1 outside our parent function or outside the base function. So that's going to cause it to go up. Vertical shift up by 1. Those are losing power, trying to make it to the end of class. Okay. That, can we see that? There we go. That's the asymptote. Okay. So exponentials have a horizontal asymptote. Normally, the horizontal asymptote is going to be the x-axis, but because we moved it up by 1, instead of it being y equals 0, now it's going to be y equals 1, right? In this instance, y equals 1. Exponentials is all reals. The very left, if you look at the graph, the far left is negative infinity, and every x to the right is accounted for. There's no vertical asymptote, there's no wall. So you can, any x going off to the right, you can find the corresponding y. So the domain for exponentials are negative infinity to infinity and beyond, right? Okay, what's the range? So normally the range for exponentials, it doesn't cross that horizontal asymptote, so it's usually 0 to infinity, the open interval, 0 to infinity. But since we moved it up by 1, now it's going to go from 1 to infinity. Okay, we're going to do 1 to infinity. Now, infinity always gets a parentheses, and again, because y equals 1 is a horizontal asymptote, it never actually touches 1. It looks like it does, but if you were actually to zoom in on the graph, you're going to find space between our exponential and the horizontal asymptote of y equals 1. So it actually never reaches the 1. So with that, the 1 actually gets a parentheses. Okay. So the graph of this is translated 7 units to the left and then 6 units upward. Let's kind of zoom in some, just a little bit, maybe one more. Okay, that seems okay. So which of the following is the equation, right? The parent function is 4 to the power x. Now, if we go 7 units to the left, that's causing a horizontal change. So we need to be inside the base function. If we want to go left, that means we need to add 7 on the inside. So that means it has to be either A or B. So we can go ahead and rule out C and D off the rip. And then 6 units up. So the 6 units up means that it's A. All right. So yeah, this is all about, these so far have been all about transformations. Just let me know, like, if you're not comfortable with transformations, my recommendation is to sit down with the tutors. I'm just trying to think of how you can pull up the chapter. Yeah, you can pull up the entire book. You can pull up the entire ebook. And there is a chapter devoted to transformations. I would just go back through that, sit down with somebody and go part by part and recap that, you know, because it's not obvious. Like the only way you would really know those transformations if you were exposed to it at some point, and what you should have been to make it here. But So using the formula for simple interest. So then let me see the time. So for exponentials, we usually like to introduce interest, the discussion on interest. And so we introduce interest with simple interest formula, right? The simple interest formula is I equals PRT, right? Principal times rate times time. So using the formula for simple, that's like the lowest form of interest that we have. Using the formula for simple interest and the given values, find I. So I equals PRT. So then basically what we're going to do is that 1314 times 13% written as a decimal, and we need to convert that 7 months to years, all right? So 13% as a decimal, you divide by 100, that's going to be 0.13. And then 7 months converted to years, or because it's 12 months in a year, it's going to be 7 over 12, right? So what I'm going to do, I'm going to do something real quick. Hey Siri, what's 1,314 times 0.13 times 7 divided by 12?
1,314 times 0.13 times 7 divided by 12 is 99.645.
99.645, right? 2 decimal places, so that 5 tells us that we need to round the 4 up, so then that becomes 65. I don't know if you knew that Siri could do math. She can. Okay, let's go with this. Cool. Let me see the time. Oh, I think that's it. Okay, we'll save some for next time, right? Okay, let's let me hop over to Zoom really quickly and just check the chat. The chat looks good. Okay. We are going to end the session here. If there aren't any questions, you guys have any questions before we part? We can attend again over the first 3 sections to be available next Wednesday, and you'll have access to it for 7 days. And then it'll be due on the 7th day, which is basically the start of the following Wednesday, the start of class. You can still work on it past the due date with only 10% late penalty. Okay, guys, if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, take care, guys. Peace.
Thank you.
All right, going once, going twice. Okay. I'm gonna go ahead and stop the stream.